This was our world 64 million years ago. The central plains of North America were underwater. Here, near the edge of the sea, it's a subtropical swamp. This is the late Cretaceous period, the time before man, although some early mammals managed to eke out an existence. They survived by eating insects, living furtively, and staying out of the way. For this is the age of the dinosaur. Some of these reptiles, like Ornithomimus, are only 7 feet tall, but their domination of the environment effectively blocks the mammal's chance for widespread development. Ornithomimus may have terrified the unwary mammals, but even for him there was danger. There was Tyrannosaur. Ankylosaur, the armored lizard, was normally peaceful, but able to fight off all comers. Not all dinosaurs were meat eaters. The peaceful Edmontosaurs were vegetarians. They probably lived communally and posed no threat to the other inhabitants of the prehistoric world. The duck-billed Edmontosaurs had better things to do than fight. Triceratops. Each egg was almost a foot long, but their chances of survival were slim. No one is absolutely sure what forces led to the extinction of the dinosaur. All we know is that about 64 million years ago, they died out. With the death of the huge reptiles, the way was now open for mammals. And it would be mammals, not dinosaurs, who would prove to be the survivors after all.
During the early half of the last century, scientists began to recognize that the fossilized bones and shells found in quarries and rock formations were the remains of prehistoric animals. Among these fossil remains were found the huge bones and teeth of what seemed to be gigantic lizards. And indeed, after more finds, more study, and much debate, it was accepted among scientists that giant reptiles, first called dinosaurs by the English anatomist Richard Owen, had once roamed the face of the earth. If we traveled back to the world of the dinosaurs, to that time called the Age of Reptiles, we would see a world very different from the one we know today. The dinosaurs ruled the earth for more than 120 million years during the era called the Mesozoic era, meaning the middle period of the Earth's history. The Mesozoic era lasted from 225 million years ago until about 64 million years ago. The Mesozoic is further divided into three smaller time segments called periods. The first period of the Mesozoic era is known as the Triassic. The second is called the Jurassic, and the third, the Cretaceous. These three periods, each of which lasted millions of years, are important to understanding that the many kinds of dinosaurs did not all live at the same time. During the late Triassic period, one of the earliest dinosaurs was an animal called Coelophysis. A meat-eater, Coelophysis probably walked on its hind legs and fed upon the abundant lizard-like reptiles that then inhabited the earth. Coelophysis grew to about 3 meters long and weighed 18 to 23 kilograms. Compared here in size to a human form, Coelophysis is a relatively small dinosaur. A relative of Coelophysis that lived several millions of years later during the Jurassic period is called Compsognathus. Compsognathus was also bipedal. That is, it walked mainly on its two back legs and was even smaller, growing no bigger than an ordinary chicken. Compsognathus probably fed on insects and small mammals, using its long legs to run down its prey. Bipedality was a characteristic common to many dinosaurs and is a trait not shared by modern reptiles. A more fundamental difference between dinosaurs and modern reptiles can be seen in how the legs are attached to the body. Most reptiles have legs held out from the sides of their bodies in a kind of sprawling position. But dinosaurs' legs were tucked in beneath the body, giving them an upright posture. This allowed dinosaurs to move efficiently and in some cases quickly, and it made it possible for some of them to attain enormous size. Another dinosaur of the late Triassic period, living at the same time as Coelophysis, is called Plateosaurus. This plant-eating animal grew to a length of 8 meters. Plateosaurus could probably stand as well on its hind legs as on all fours, allowing it to reach to the tops of trees for food. During the Jurassic period, a relative of Plateosaurus evolved into what has become the best known of the dinosaurs, Apatosaurus, or as it used to be called, Brontosaurus. The Apatosaurus could reach a length of 21 meters and weigh as much as 30 tons. Apatosaurus must have eaten continuously to support such a massive body, probably feeding on the leaves of tall trees and on the vegetation growing around lakes and marshes. Here, compared to its more ancient relative, Plateosaurus, and to a human form, Apatosaurus can be seen as a true giant. But Apatosaurus was not the largest of the dinosaurs. Brachiosaurus, a relative of Apatosaurus that also lived during the late Jurassic and early Cretaceous periods, reached a length of 23 meters and weighed 77 tons, more than twice as much as Apatosaurus. But fossil remains of an even larger dinosaur have been found. The neck and shoulder bones of 2 dinosaurs found in western Colorado suggest an animal that stood 17 meters tall with a full body length of some 25 meters. This giant has been called Supersaurus. And yet, a dinosaur called Ultrasaurus seems to have been even larger. The remains of this dinosaur suggest an animal in excess of 30 meters long that may have weighed as much as 130 tons. If alive today, Ultrasaurus would be able to look over the top of a 5-story building. Fossil records indicate that there were actually 2 distinct biological orders of dinosaurs. The animals discussed so far, like Apatosaurus and Coelophysis, are animals grouped as Saurischia, or reptile-hipped dinosaurs. As we have seen, some of the reptile-hipped dinosaurs were carnivores, meat-eaters. The other order is the Ornithischia, or bird-hipped dinosaurs. All of the bird-hipped dinosaurs, like the ones shown here, were herbivores, plant-eaters. The names of the 2 groups, bird-hipped and reptile-hipped, are based on differences in the bone structure of the hip or pelvic region. The bird-hipped dinosaur called Iguanodon is interesting because its fossilized bones were the first recognized as coming from ancient reptile-like animals. Iguanodon was plentiful in much of Europe toward the beginning of the Cretaceous period, some 125 million years ago. Remains of Iguanodon are frequently found in groups, suggesting that these plant-eating giants traveled in herds, like modern-day elephants. The Iguanodons had large spiked thumbs that may have been used as a defensive weapon in case of attack from carnivores. Another group of bird-hipped dinosaurs that probably lived in groups were the corythosaurs, or crested dinosaurs. These animals were members of a subgroup of dinosaurs called duck-billed because of their flat, bony, beak-like mouths. An even more startling crest was found on another variety of duck-billed dinosaur called Parasaurophilus. This species survived until the end of the Cretaceous period, only to perish along with the rest of the dinosaurs during what has been called the Great Dying. A remarkable fossil find in western Montana in 1978 indicates that myosaurs, another form of the duck-billed dinosaurs, laid their eggs and cared for their young in communal nesting sites. The reasons for herding and communal nesting were probably defensive. Because if the plant-eaters were large at the end of the Cretaceous period, so were the meat-eaters. Tyrannosaurus rex measured up to 15 meters long, the largest of the carnivorous reptile-hipped dinosaurs. Using its massive head, strong jaws, and dagger-like teeth, the Tyrannosaurus was probably a fearfully efficient predator. Tyrannosaurus rex means king of the tyrant reptiles. And during much of the late Cretaceous period, this fearsome beast must have terrorized the more tranquil plant-eaters. But many of the late Cretaceous plant-eaters developed other defenses against the ferocious predators. Protoceratops, which measured only 2 meters long, was one of the earliest of the horned-faced or ceratopian dinosaurs. The ceratopians seem to have lived only toward the end of the later Cretaceous period, but at that time became quite abundant. Triceratops is probably the most famous of the ceratopian dinosaurs. A plant-eater, Triceratops must have been something like a massive 9-meter-long, 6-ton tank. With its 3 horns and its habit of living in groups, the Triceratops was probably a combative match for even the fiercest of tyrannosaurs. For more than 120 million years, these dinosaurs and many others, some like them and others even stranger in appearance, ruled the earth. What we know of the dinosaurs is based on scientific examination of their fossil remains. Much about their behavior, their coloration, the workings of their bodies, and their final disappearance from the earth may never be known. But the study of their lives and deaths has provided a rich field for scientific theory and debate. Not long ago, some scientists put forward the notion that dinosaurs were not cold-blooded or ectothermic at all, but perhaps warm-blooded or endothermic, that is, capable of regulating their internal body temperatures like birds and mammals do. These scientists argue that the bone structure of many dinosaurs suggests a continuously active life, more like the lives of warm-blooded animals than like the relatively sluggish lives of most cold-blooded reptiles. Another recently debated theory suggests that birds are direct descendants of dinosaurs. The fossil remains of the remarkable feathered animal Archaeopteryx show that it shares over 20 features in common with certain kinds of dinosaurs. Could it be that Archaeopteryx was a feathered, flying, direct descendant of dinosaurs, and that its descendants, the birds, survived the great extinction of the other dinosaurs? Could it be that even today descendants of dinosaurs live on in the form of pigeons, sparrows, robins, and seagulls? These are just a few of the questions in the modern study of dinosaurs. The greatest mystery, however, remains. Why, after over 120 million years of successful evolution, did the dinosaurs, at least in their best-known forms, disappear from the face of the earth? The dinosaurs were not alone in the great dying at the end of the Cretaceous period. Other forms of life, like the flying pterosaurs, the sea-going plesiosaurs and ichthyosaurs, and even a form of microscopic plankton, became extinct at this time. In their search for an explanation, many scientists believe that a long but continuous change in climate finally led to the extinction of these life forms. They point to indications from the geologic record that the plant life of the Earth gradually changed during the last part of the Cretaceous period. Perhaps the climate became very cold and typical food sources became more scarce, and various of the plant-eating dinosaurs began to die out. If the plant eaters died, so would the great predators like Tyrannosaurus. Other scientists, based on their reading of the geologic data, argue that the mass extinction of this period was more abrupt. An intriguing discovery of a layer of a certain mineral-laced deposit that seems to coincide with the period of the Great Dying has suggested a cosmic explanation. Perhaps this deposit is the result of a comet or an asteroid striking the Earth and raising great clouds of dust and steam into the upper atmosphere. If this had happened, the resulting cloud would have blocked out all or most of the sun's light for months on end. Without light, plants and then animal species, especially the large and specialized species like the dinosaurs, would have died out in catastrophic numbers. In any event, 64 million years ago, a great change happened to the Earth and its inhabitants. The dinosaurs vanished. But during that time period, the ancestors of crocodiles, turtles, birds, and most importantly for us, mammals survived, bringing a new order to life on this planet.